Welcome to the last day of the Academy and the last lecture. The focus of today will be on how you can contribute to the Jedi code base and become a developer yourself. So there will be three parts to the talk. We'll start by reviewing our agile approach to project management. You've heard a bit about this already on Monday's lecture and throughout the week. It's based on Git and GitHub, which you've been using throughout the week. Also talk about the Git flow paradigm, which governs how we create branches and it governs the pull request and code review process. And I'll talk about how you prepare to contribute your code and then actually issuing a pull request and participating in the code review process. And we'll continue exploring this with the activity that will follow. So in the second part, I'm going to focus on the usage model in which you would be an external collaborator. So you would start from the public JCSDA repositories, and then you would create a fork either in your personal GitHub account or at an institution, and then create feature branches and bug fix branches there. For many of you, this is not the way you will work. For many of you, you already have access to the internal JCSDA repositories. So there you will create your feature branches and bug fix branches on our internal repositories. So that particular model regarding forks will not apply to you. So the way of a Jedi is collaborative. We've spoken this week about the Joint Center and our partners and stakeholders. This is a community, and the Jedi Project itself is also a community project, and we welcome contributions from external developers at universities and other centers. So this distributed team of software developers, we use Git and GitHub to help coordinate them across different time zones and even different continents. And we take an agile approach. So we're collaborative, we're also agile. What agile means, we mentioned this a little bit in the previous lectures, particularly on Monday. But the idea is there are specific agile models such as Scrum or Kanban. We don't follow these specific models, but we follow the general agile philosophy, which focuses on innovation. It focuses on flexible code. We know code is future proof, but we don't know what models will be there in 5 years or 10 years. We don't know what observations and new satellite systems will be up in 5 or 10 years, but we want to design Jedi to be flexible enough to incorporate them, whatever they may be. So that is a guiding design principle behind the project. We want to be useful, responsive to users and developers. So that's another core agile principle that you may start out with a set of requirements, but those requirements may change, and we have to be able to adapt to the requirements as they change. And the bottom line in any agile process is the continuous delivery of functional software. We have to deliver things that work. So it's more important to deliver something that works than to hold back until all the requirements are met, because that's never the case. The requirements always change, and there's no comprehensive code that's going to do everything. We just continually make it better. So the core 12 agile principles that underlie the various agile approaches that they have in common. Again, early and continuous delivery of valuable software. Number 7 down there, working software is the primary measure of progress. So that's an important key. We want to deliver working software, self-organization of teams, and number 12 is an important one. Teams regularly reflect and adjust their behavior accordingly. So being able to adjust to changing circumstances and changing requirements. So some of those are the principles behind the approach, the tools we actually use to implement this. You've seen how Git works throughout the week. So Git is the version control system. GitHub is the online repository host platform. And so this is what we use for version control, for distributing our releases, for doing pull requests and code reviews, and for coordination of our distributed community. So if you issue a pull request and you review the code, this can be done asynchronously across different time zones, and you can and people can collaborate in this way. We also make use of GitHub teams to do the same sort of thing, bulletin board type things to coordinate our distributed community. The teams are mainly internal to those specifically that have access to our internal repositories. But there's also the Git flow paradigm that everybody will follow, whether you access our internal repositories or our public repositories. You'll be expected to follow this paradigm. This simultaneously promotes innovation and continuous delivery in a way I'll talk about in a few moments. We also use ZenHub. ZenHub is an extension to GitHub. I won't talk about it today in this talk. It's mainly for our internal use, but it's a useful extension to GitHub that we use for agile project management and issue tracking and enhanced code review. And in addition to normal issues and pull requests, we have ZenHub enables things like epics and milestones and estimates on how difficult the different tasks are. If you don't have access to creating ZenHub issues directly, then you can use our forums. So our forums, you can post questions to the forums, and people from the Jedi team or the broader community will get back to you and work with you on any questions you may have. So as I said, Git is the version control system, and GitHub is the web-based repository management. So you've already seen how some of this works in the various tutorials this week. So each repository has different branches. The protected branches, the main branches, are develop and master in each of the Jedi repositories. So any changes to develop and master, you have to do through pull requests. The terminology of pull requests is for those new to GitHub or Bitbuckets or similar repositories, it can be a little confusing, but the idea is that you are requesting that the project, in this case Jedi, pull your changes into the code and incorporate them into the code. So that's why it's called a pull request. So Git flow is something different than Git and GitHub. Git flow is multiple things. It's mainly a philosophy. It's an optimal philosophy for agile software development that, again, as I said, promotes both innovation and continuous delivery. So the bottom here is where this originated. I'm calling it the Git Flow Manifesto. This is the original blog post by the software engineer Vincent Dreisen from 2010. That link is still active, and I highly recommend, we all highly recommend that you go to it and read this article. It's a brief article, it's not very long, but it's a nice distillation of what the Git flow paradigm is and why we use it and why it's useful. So Git flow is also a working principle. So there is enforcement of the branch naming convention. So if you do a pull request to JCSJ repositories and they do not follow the Git flow naming convention, then you will be scolded. We have a webhook, an automated webhook that will check for compliance with Git flow. So be aware of that. And it's also an actual application. It's not required to use this, it's optional, but there's an optional extension to Git that is already installed in the Singularity container that you've been using all week. And this just facilitates creating branches and pushing branches and publishing branches within the Git flow paradigm. So next I wanted to exit this and show you the diagram that comes from that article, that blog article that I mentioned on the previous slide. So this is the idea. So time goes downward, proceeds downward, and this illustrates the different branches that exist within the Git flow paradigm. So, and the The circles here represent commits or code changes. So there are two permanent branches in boldface, the develop branch, the master branch. The master branch houses the public releases. So any commits shown by the arrows to the master branch get a tag. So they're available on the public repositories and they get an official tag. But the develop branch exists over here. And most of the development occurs along feature branches. So feature branches are temporary. They branch off of develop, you make your code changes, and then you merge them back into develop. And when they're merged back in, they no longer exist. The branches are deleted once the code is merged into develop. And so this is where the development happens. In order to merge back to develop, they have to pass tests. So as you're working with them, they may not pass tests, but in order to be merged back to develop, they have to pass all tests. They have to be documented. And then another type of branch in the Git flow paradigm are the release branches. And the idea here is that this branches off of develop and you create a release branch, and then you may add more documentation to it. You may add tests, you may clean it up a bit. And eventually when you're done and it's ready for the public, then you would merge it into master and tag it. And you would also merge those changes back into develop so that the new tests and documentation you added are there in the code base. So that's what the release branch is. And the way, this is one way that Git flow, the approach emphasizes both continuous delivery and innovation at the same time, because while this relatively stable release branch is just being fine-tuned and eventually published, there's still development going on with the feature branches and the develop branch. So there's still new branches being created, branches being merged in. So the develop is still evolving even as you're preparing for a release. So this is highly efficient. So there's another type of branch called a hotfix, which comes off of master. So this is when you see a bug in the released code, you can branch off of master, fix the bug, and then branch it back into master. But you want the fix to also be incorporated into the develop branch. So that's the hotfix. There's also, not shown on this diagram, there's also a type of branch called a bug fix branch. That's the same as the hotfix, but the difference is that a bug fix usually branches off of develop and branches back into develop. So the hotfix is off of master, the bug fix is off of develop. So that's the idea from Git flow. So the takeaways from that manifesto: the master is for releases only. The develop branch is not quite ready for release, but it has to compile and it has to pass all the tests. So if you have code that you're working on that is not complete yet and doesn't pass tests, that would likely exist in a feature branch. This is where most of the development happens. And as we've emphasized all week, it's highly advised that your feature branches should be brief and focused. They should exist for days or weeks. They should not exist for months. So that you should make a change, and when a feature is implemented, then you can issue a pull request and get it merged in, and then you can continue to develop and you can continue to expand on it in the future. But it's much easier for the code reviewers to see what you're doing if the pull request is relatively small and focused. So break up a big complex feature that you're adding into bits and do a pull request on each one of those bits in turn. And again, we have hotfix and bug fix branches, the main difference being where they branch off of. The hotfix is in the released code, whereas the bug fix is something from develop typically. So to prepare to contribute, as I said, we're going from the perspective of an external collaborator from an institution outside of JCSDA, and someone who, if you have access to our internal repositories, then this would look a little different. But if you're If you're an external contributor from a university or another organization, then you would start from our public repositories at the JCSDA organization on GitHub. And then in the upper right corner there, you see a button to create a fork. So you can create a fork, press that button, and you can fork this to your own individual GitHub account or to an institutional GitHub account, and then work from that fork. So, and then on the command line, using the Git command line tool, you would first clone that repository that you created, your fork. So there, my account would be replaced by your personal GitHub account or your organizational account where the fork exists. So you would clone the fork, you would CD to that directory, and then any Git repository, any local Git repository can have multiple remotes. So the origin here would be your account or your fork, but you would want to add an upstream as JCSDA. So this is an example for UFO. You could do a similar thing for OOPS or Saber or FE3 Jedi or any of the other public repositories. And so you would add the JCSDA GitHub organization or GitHub repository as the remote, as the upstream remote. And then you do a fetch of the upstream information. This fetches the branches and the tags from the JCSDA repository, the upstream. And then you would check out develop, but if you do a -- track upstream develop, so now there are two develops, right? There's the develop on JCSDA and the develop on your fork. But you want to make sure that your feature branches are created from the develop branch, the upstream, the JCSDA branch of develop. So to do that, you would do this -- track upstream develop means that your local develop branch on your computer will now track the JCSDA develop branch. And then you can create a feature branch from JCSDA develop. So this command down here, the git checkout -b means to create this branch from the develop branch at JCSDA. And then you would proceed by making your code changes, and then you could do a normal git add. After you add files, you should always do a git status to make sure that the files you're committing are the ones you intend to commit. For example, you might have accidentally included your build directory in your repository, and you don't want to accidentally commit all your .o files and .mod files and such. So it's always good to check on that. And then when you're ready, do a commit. And then the first time you create this branch, you would do a git push to origin to your fork. And then this -- set upstream it creates the feature branch on GitHub. And then for future pushes, you can omit that. You can just do a git push. So you had created this branch locally, and now you have pushed it to GitHub. And again, we'll do that in the activity this afternoon. So then you continue to make changes, you commit them, push them, and test them. And periodically while you're doing this, again, hopefully it will be over the course of days or a few weeks and not over the course of months. But in any case, you should periodically make sure that your feature branch is up to date with the JCSDA branch of develop, because that will be changing on a day-to-day basis. So on a daily basis, once every day or once every few days, you should check out the develop branch. You should pull from the upstream, and then you should check out your feature branch and merge the develop into your feature branch and fix any conflicts that might arise. This is necessary because when it eventually becomes time for you to commit, do a pull request to contribute your code to JCSDA, it has to be up to date to develop. If it's not, then your pull request will be sent back to you and you will be asked to please incorporate the latest changes from develop before you issue this pull request. So that's important to keep in mind. It's also important to test and document your code. So as Mariam spoke about in her lecture yesterday, that if you add some code and you do not, and that code is never executed in any tests, then your code will fail the CI testing that we have. We have something called CodeCov that tests code coverage. So if you have added, it's both on a global scale and it will also check the differences. So if you added code and that is not tested, then it will fail the CodeCov test, and it will not be merged into the develop branch. So it's important to make sure your code is tested. And for further information on that, see Mariam's lecture from yesterday. And it's also important to document your code. So explain how to use this new feature, what its purpose is, any background mathematical or scientific information about it, any known limitations or bugs. So there are two ways to document your code. Ryan in his lecture mentioned this Doxygen document generator. Both Doxygen and Sphinx are written in Python, but the difference is that Doxygen commands are embedded within the source code, so within the Fortran and the C++ code, whereas Sphinx is separate. So the Sphinx documentation is what you find on our Jedi docs, read the docs documentation page. So the low-level Doxygen is low-level descriptions of functions and classes and such, and the higher level description of the context of the repositories and different functions and the theory behind them. These are the high-level documentation and the different use cases. So that is also just a repository in our public GitHub account, JCSDA. It's called Jedi Docs. And that is ultimately where that published documentation comes from. So in terms of documenting Fortran source code, here is an example. It comes, so you have this is a Doxygen block here. It starts with this bang greater than sign at the top. I don't think I have a cursor to point it out. But so it starts with that bang greater than sign. So and then it includes a number of directives. There's this /brief and /details. So the brief is a brief description. Details is further information. Those two asterisks there indicate that or demonstrate that Doxygen understands markdown format. So that would be boldface. And then this is a markdown list here, the item 1, 2, and 3. That is a standard markdown list. And there are other directives, date and warning. If there are any known limitations to or known bugs to this function, then you might include it in a warning block. And then the function itself, the parameters of the function, you can have this bang less than sign at the end of each argument declaration. And this is understood by Doxygen, and it will come out in the output, as you'll see in a few pages. So Doxygen does have difficulty with object-oriented Fortran. So if you, particularly methods and derived types, it might not follow them correctly. And it has trouble with Fortran C++ bindings, as you'll see. But still, please do add it to Fortran code. It's still, the documentation itself shows up. This is that same example shown in C++. So there again, it has the same directives, the /brief details. Here the code block is started with a /* bang exclamation point. And there, instead of, as you see, the parameters here in the Fortran case had on the line, it had that bang less than sign with the A, B, and C parameters. Here they're explicitly included in declarations with the param directive and intent in or intent out. And here are some of the Doxygen commands you can use. We've already talked about brief and details, and there's date and author and warnings. And up in the upper right there are formulae, so it understands LaTeX, so you can include displayed or inline formula, many more at this website. So here is an example this is what it generates. So when you, those Doxygen commands, when you crunch them through the Doxygen executable, it produces HTML pages. This is a sample man page. This is the test state interpolation. There is a boldface, what it looks like in boldface. There's a list there. There's a displayed equation. This is what the actual code looks like. This is C++ code. So it starts with that slash asterisk bang, and there's the list, and you can see where the boldface is indicated. And on the next page here, this is where the equation is. It starts with that slash F, so that's in LaTeX. So some of the diagrams that Doxygen generates, this is one example, a class hierarchy. So here you can see, for example, that oops test is a subclass of oops application, and then oops test itself has all these other subclasses. So that is useful. Then it also has include diagrams. So this geometry.h includes all these files, which in turn include other files. So you can see that on the output. And you can go in and click on each one of these boxes too. So you can go, for example, click on function space. Well, that would be outside of oops. You might go to click on oops. It's best to stick within a repository. So you could click on oops mpi.h and that will come up. So then it also has call graphs. So this fill geovals command calls these other commands, fields, get values in terp, F90, etc. It has caller graphs. So this routine here, QG fields copy, is a Fortran routine, and it shows all the routines that call it and the routines that call them. And so this is what I was talking about in terms of Doxygen not understanding the C++ Fortran binding. If you follow this call graph over to the left, you'll see that each one of these lines ends in something in a function name, Fortran function name with that ends in _C. That is bound to a C++ function that Doxygen has trouble following. So in order to follow this chain further, so this is being called from C++ in all these different cases. So to follow this chain further and see which C++ commands are calling them, you can look for the corresponding, each of these _C commands has an _F90 command that is a C++ routine that is bound to the Fortran routine. So you can look for those and you can follow this dependency graph further. So to use Doxygen in Jedi, first at the bottom of the page, for our releases, we publish the HTML output of the Doxygen for each of the repositories, oops and Saber and Yoda and UFO and FE3 Jedi. These are available on the Academy website and the main documentation website. But if you add your own Doxygen documentation and you want to see what it looks like, then first you would have to install Doxygen and this thing called GraphViz, which is needed to generate the graphs I just showed you. So you can install this with your favorite package manager, Homebrew on Mac or apt or yum on Linux. And once you have it installed, then you can build the documentation for a particular repository. This is oops as an example with the enable doc flag. So here it's enable oops doc, and you set that to on, and then you compile your bundle as you would normally. And then you could find the HTML results in the subdirectory. In this case, it would be off the build directory. It would be the subdirectory oops docs HTML. So UFO and Saber and FE3 Jedi also have, and Yoda have also have Doxygen flags that you can enable. So the second type of documentation is higher level documentation that you've seen on the Read the Docs site. So this includes overview type information and includes details about the mathematical or scientific background. Here is an example for BUMP. So there's nice documentation on BUMP available from the website. And again, that accepts LaTeX type commands. So this, as I mentioned, is just a repository like any other one. So this is a repository called Jedi Docs. It's available on our public site. And just like any other code repository, you can fork it and create a feature branch and submit a pull request. So you are encouraged to write your own documentation for the features that you add. So this is, if you look into what the code actually looks like, if you download this Jedi Docs repository and look at the actual files, they are RST files, restructured text. So the documentation is published on Read the Docs, but what actually does the work is this thing called Sphinx, this document generator called Sphinx, which converts the RST files into HTML files. So you can write, you can add documentation as RST files and then run Sphinx on it, and it can generate the documentation. So for information on how to run Sphinx, that's available on our documentation pages. So the last part of this talk is how you actually contribute code through pull requests. So again, I'll go under the assumption here that I'm an external collaborator and I'm working from a fork. So this is a fork of UFO in my own personal GitHub account. This is forked from JCSDA Academy, but normally you would fork it from the JCSDA, the main public JCSDA repositories. So this is a fork. So you would go to your GitHub, you would go to your forked repository, and then you'd select your branch from the drop-down menu, and you would press the pull request button to issue a pull request, and that would bring up a next page. So here, the most important thing here is this line to make sure that the source and destination code are correct. So the source of what code you want to merge into what code. So on the right is the source. So that comes from my personal fork of UFO, and the branch is this particular feature branch. And then it's important that on the left, where this is going, see the arrow in between going from right to left. On the left, it's important that the base repository, the organization should be JCSDA, and the repository in this case is UFO. And the branch should be developed following those Git flow conventions. So you would want to merge all your feature branches or issue your pull requests always to the JCSDA UFO repository in the develop branch. So that's important to get right. And below this, it will tell you if there are conflicts. So this is, again, why it's important, another reason why it's important to make sure your branch is up to date with develop. So periodically, especially, you should do it every day or two, but especially before you issue a pull request to pull the latest develop from JCSDA and merge it into your code and fix any conflicts that may arise. If there are conflicts, then it will show up here, and your pull request will not be approved if there are conflicts. So you have to fix them at some point, and you save your code reviewers some time if you do it before you actually issue the pull request. So this is, again, part of the dialog box that comes up when you issue the pull request. So give your pull request a good descriptive title and description. So there's a template here where you can fill out the various parts of this as it's described here, and it will ask you questions and you answer them. Things like, what does this pull request do? And there's an important agile type principle is the definition of done. So this feature branch is done and ready to be merged. What does that mean? What can the code do now that it couldn't do before? So what does done mean? So often, if you're an external collaborator, the Jedi team will assign reviewers for this. You can, in the description, you can suggest reviewers. If you have access to our repositories, either the internal repositories or our public repositories, and as an external collaborator, then you will be able to select the reviewers yourself. So we will do that as an example in today's activity. And then when you're ready, there's a big green button on the bottom that says, go ahead and create the pull request. So some comments about that. Again, make sure your feature branches are short and focused. They're more likely to be reviewed quickly if they are short and focused. If you've changed 100 files, then it might take a few weeks for people to really understand and appreciate what you've done. Fill in the requested information in the template, give it a good description. What does it mean for it to be done? Refer to relevant conversations. This might be a Zen Hub issue if you have access to our internal boards, or it might be a thread on our public forums. And identify appropriate reviewers and make sure it's well documented and tested. And be willing to change your code in response to reviews. So if there's something that often is the case, more often than not, a reviewer will suggest a change, and then you'll often make it and then push your code again, and the reviewers will see it. And then when everybody's happy with it, it will be approved and eventually merged into develop and eventually incorporated into master in the next release. But also it's important to read the working principles and best practices for developers sections of the Jedi documentation. It only takes a few minutes to read these, and they're very important and give further details on everything that I have talked about today. So the last thing is that you may be requested to participate in the code review process as a reviewer. So the thing to know about that, the main thing to know is that the purpose of the code review is to ensure that the overall health of the code improves over time. And what does health mean? That includes the scope and functionality of the code, what it does, the clarity of the code, the efficiency of the code, and the reliability, robustness. So, and any of these aspects is an aspect of the health of the code. And to be useful, a code review must be timely. So if you wait 2 weeks before looking at the code, then it's likely that somebody else will review it, and it'll be merged before you even get a chance to look at it. So if you're asked to do a review, do it in a timely manner. Be courteous and reasonable. So remember, there's no perfect code, only better code. So we don't have to be perfectionists. Just, does the code improve the health of the base code, and does it do what it's intended to do in an efficient and clear manner? And if it does, don't be overly picky about it, but do be critical when needed, and constructive criticism. And additional benefits has been, as has been mentioned multiple times this week, that doing code reviews is a good way to learn about the code, both for new users and for experienced users. So new Jedi users, it's a good way to see how things are done in Jedi. And often even experienced users will look at code. I still learn a lot from pull requests, seeing things that are done that I didn't know how to do before, and so it's a good way to build team, to build knowledge, and just improve the overall development process. And it can also be used to impose a consistent style. For example, our style is usually to use lowercase in Fortran programs. So a reviewer might notice this. We have automated checks for C++, but we don't have that yet for Fortran. So a reviewer might ask you to, make this function name, subroutine name in Fortran lowercase. So a few questions to ask yourself as a reviewer. Again, does the proposed code that this person wants to contribute, does it improve the overall health of the code? Is it clear what is being done? Does it achieve what it says it wants to do? And And could it be done? Could this goal be achieved in a more readable or more efficient or more generic manner? Is there, are there print statements or unnecessary include statements that have been left in unintentionally? And is the new code adequately tested and documented? And again, if it's not adequately tested, then it's going to fail the CI testing. And as as was mentioned, I think by Miriam, that there's in our public repositories, there's one round of CI testing, but internally, there is a more comprehensive round of CI testing that's done with 3 different compiler suites, Intel, CLang, and GNU, and further code coverage tests. So it will need to pass all the tests before it's merged. And another consideration is, does this code belong in the Jedi code base, or does it belong in the Jedi stack as an external library? And then you yourself as a reviewer should read the relevant sections of the Jedi documentation. So what are those? The working principles section is just in the top level of the documentation of the table of contents, and it has a lot of good tips on reviewing code and testing and creating documentation. And the best practices is if you go to Inside Jedi, you can find it there in the table of contents. And there's further tips on using Git flow and creating meaningful pull requests and issues. And again, more information on documenting. And that's it for this lecture. So we'll follow this with an activity where you'll be doing many of the things we spoke about in this lecture, but just as a summary, for many of you external collaborators, you would work from forks, but whether you're working from forks externally or accessing our internal repositories, either way, you have to you're asked to follow the Git flow principles, in particular the branch naming conventions, and make sure any code you contribute is well tested and documented. Submit code through pull requests. Make sure the pull requests go to the JCSDA or JCSDA internal, in some cases, the develop branch. Make sure that the source and destination code for the pull request is appropriate. And realize that your code will be subject to CI testing, and so make sure it passes all tests. It will not be merged into develop if any tests fail. That includes the tests that you write, as well as any other tests that might execute the code. And realize that you may be asked to do code reviews as well. And we will stop there. And questions are welcome.